Hello everyone. In this video, we are going to talk about a problem that we got from one of the math competitions. In this problem, we have Sn as some of the digits that we have for a number n, and for this problem, n is defined between 0 and 10 to the power of 5, and it is an integer. We want to find number of cases that we have with Sn is equal to 14. In other words, we want to find all possible cases that sum of the digits in n between 0 and 10 to the power of 5 is equal to 14. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem. To solve this problem, we are going to start with using a new notation for n. We know n is less than 10 to the power of 5, so n can be 1, 2, up to 10 to the power of 5 minus 1. As a result, n is going to have at most 5 digits. Let's use the notation that we have for n as d4, d3, d2, d1 and d0, where d0 is the rightmost digit and d4 is the leftmost digit. Remember, the values that we have for d0, d1, d2, d3 and d4 can be 0, 1, 2 up to 9. With this new notation, we can define Sn as the sum of d0, d1, d2, d3 and d4, and we know Sn should be equal to 14. For a moment, let's review what we know. We know sigma di for I between 0 and 4 is equal to 14, and we know each di is going to be between 0 and 9, including those numbers. Here, let's review a very known problem in combinatorial mathematics, the problem called stars and bars. In this problem, we want to find how many ways we can put n indistinguishable balls into k indistinguishable bins. There are two theorems related to stars and bars. In the first theorem, we have x1 plus x2 plus x3 up to xk is equal to n. Each xi should be greater than 0. For this problem, the total number of cases that we have is going to be n minus 1 choose k minus 1. In the second theorem, we have the same problem, but here each xi can also be 0. For this problem, the total number of cases is going to be n plus k minus 1 choose k minus 1. So let's go back to the problem that we have. In this problem, we have d0 plus d1 plus d2 plus d3 plus d4 is equal to 14. And we know each di is greater or equal to 0 and should be less than or equal to 9. So for the case that it should be greater than or equal to 0, we can use theorem 2. The total number of cases that we have to meet just di greater or equal to 0 is going to be 18 choose k. However, we are ignoring the fact that each di should be less or equal to 9 here. So there are cases that we need to remove from this number of cases that we have. Let's review how many cases we have where di for I is equal to 0, 1, 2, 3 or 4 can be greater than 9. The minimum value that we have here is going to be 10 under this case. If one of the numbers is going to be 10, others cannot be more than 4. So we need to rewrite the equation to meet this condition. Here we are going to use a new notation to simplify the expression. Let's assume that d0 is at least 10. So we can write d0 as 10 plus u0, where u0 is going to be 0 or anything greater than 0. Then we can write Sn as 10 plus u0 and then d1 plus d2 plus d3 plus d4. Sn should be equal to 14. If we remove 10 from both sides, then we have u0 plus d1 plus d2 plus d3 plus d4 is 4. Here u0 is at least 0, and d1, d2, d3 and d4 are going to be 0 or anything greater than 0. Now you can see that the total possible cases that we have to meet this condition is going to be 8 choose k, using theorem 2 that we showed before. But we just considered d0 to be at least 10. There are cases that d1 or d2 or d3 or d4 can be at least 10. So we need to consider all these cases, and there are 5 of them. So in total we have 5 times 8 choose k cases that we need to remove. Accordingly, the total number of cases that we are going to have for this particular problem is going to be 18 choose k minus 5 times 8 choose k, and that's our answer. For this video, I'm going to show the code that I wrote to verify that the answer that we found is indeed correct. It starts with importing the library that we used to calculate n choose k. Then we set the total number of cases as 0, and then for each number between 1 and 10 to the power of 5, we started with finding the digits that the number has and then calculating the sum of the digits. If sum of the digits is 14, then we increase the counter, and at the end we printed the counter, and we also compared it with the formula that we found previously. To wrap up, let's summarize what we've done to solve this problem. In this problem, we defined Sn as sum of the digits, and we wanted to find number of cases that we have Sn is equal to 14 if n is a positive number less than 10 to the power of 5. We showed that to meet this condition, each number should have at most 5 digits. Then we define this Sn as a new problem when we have Sn is equal to d0 plus d1 plus d2 plus d3 plus d4, and each di is going to be at least 0. We found the total number of cases. Because of this problem, each di is not going to be anything more than 9. So we needed to remove all the cases that are not allowed. We found those cases, and then we calculated the final answer using a subtraction. Thanks for watching the video. If you would like to see more puzzles and math involved activities, please subscribe to the channel.